Your omega-3 supplements may be causing more harm than good, and we'll be explaining why today in episode 106 of the Energy Balance Podcast, a podcast where we explore health and nutrition from the bioenergetic view and teach you how to maximize your cellular energy to maximize your health. Today's episode is part 2 of a 3-part series exploring the relationship between omega-3s, mortality, and lifespan. And in today's episode, we'll be going over the studies showing that fish oil and cod liver oil supplementation increase oxidative damage in humans, even in the triglyceride form, alongside antioxidants. We'll also be going over why omega-3s are harmful in both healthy and unhealthy humans, the harmful metabolic and hormetic effects of omega-3s, and why omega-3s are not beneficial due to hormesis. And we'll also be going over the research showing that omega-3s do not improve chronic health conditions or mortality in humans. To check out the studies and articles and anything else that we reference throughout today's episode, head over to jfeldmanwellness.com/podcast, where you can find the show notes for today's episode. And with that, let's get started. Anyway, that brings us now to the studies looking at the actual consumption of omega-3s in humans and the direct effects of that. And so we'll be looking specifically at how, just like we saw in that rat study, increasing the consumption of omega-3s in humans, both from fish oil and from EPA and DHA individually, increases lipid peroxidation, which of course is associated with decreased lifespan, increased aging, and is generally something we would argue is a reason not to consume these things in large amounts or not to go out of our way to consume it, again, despite the association studies. And I did want to make a point here. I believe it was when I was talking with Dom, if not, it might have been somebody else, but I think it was with him. He mentioned that he thinks there could be a difference between consuming EPA and DHA individually in the ethyl ester form versus consuming fish oil in the triglyceride form. Maybe it was Thomas DeLauer. I don't remember who mentioned that. But that doesn't seem to be borne out in the research, and I made a point here to include studies looking at both fish oil, which would be in the triglyceride form, and EPA and DHA individually, and it doesn't really suggest that fish oil is any better. So just wanted to mention that real quick as we get into these studies.
Yeah, I don't have too much to add there.
So in this first study, it's titled Mitochondria, Omega-3 and the Route of Mitochondrial Reactive Oxygen Species. And this is just a kind of overview paper where they discuss this as a whole. It's not digging into, it's not like a specific individual study, which we'll be getting into after, but it's kind of a good summarizer. And so they state dietary intake of omega-3 polyunsaturated fatty acids, and consequently the increase in omega-3 content of membrane lipids may be disadvantageous to health because reactive oxygen species-induced oxidative peroxidation of omega-3s within membrane phospholipids can lead to the formation of toxic products. The susceptibility to peroxidation of PUFAs by ROS raises the question of the adverse effects of omega-3 dietary supplementation, in this case specifically on embryonic development and prenatal developmental outcomes. So of course, omega-3s are suggested for those, in that population, women who are pregnant. And this is questioning whether it's a good idea. They then go on to state that dietary supplementation of omega-3 PUFAs is known to induce lipid peroxidation in organ and tissues of women and animal models. The consequence of PUFA supplementation is toxicity related to the end product of lipid peroxidation. Dietary intake of omega-3 PUFAs may therefore be detrimental to cellular function, as the peroxidation of these fatty acids by ROS can induce the formation of toxic products, which is potentially mutagenic and atherogenic. The disturbance in the cellular redox balance and associated damage to membrane integrity and mitochondrial function has been identified as causal factors of chronic inflammation, atherosclerosis, and neurodegenerative diseases. We'll be digging into specific studies, looking at what happens when you give this group fish oil and what was the result. But this is just kind of an overview, looking at a handful of different studies and just sharing some general ideas as far as why we might want to be concerned about things. And just, the reason I included this is because I think it's important to have that direct corroboration in the research.
Yeah, I know there's going to be some people in the audience who are going to be like, well, there's this study that says that fish oil does this or does that, or it's actually an antioxidant. And in some studies, it does show this antioxidant function, but it's not because it's not being peroxidized. What winds up happening is the fish oil or the omega-3 fatty acids are so liable to peroxidation that they do indeed peroxidize both spontaneously and from enzymatic processes. And then the mediators that they produce actually signal cell defense responses to minimize oxidative stress. Like they're some of the most potent signalers. They interact with the same gene elements that respond to things like cigarette smoke and diesel exhaust and things along those pathways. Just in terms of like their signals of a degree of toxicity. The lipid peroxide signal all of these different pathways. Now, there are some mediators that have this and that effect specifically, but in general, there's a general upregulation of a lot of the lipid peroxidation products, both from omega-3s and from omega-6s, in interacting with the specific pathway is called the NRF2 pathway. We're not going to get into that inside this specific podcast, but it's a defense pathway. So it's a hormetic response, but it's functioning through lipid peroxidation, which is just not ideal overall.
Yeah. And one of the studies that we will go through here talks about the activation of PPARs and other increases in beta oxidation enzyme activity.
Yep.
In the same vein of this hormetic response, which we'll discuss. It's a great point, and I would recommend that anybody who is not familiar with our view of hormesis goes and checks out that series that we did and a couple articles I wrote on it as well. Because, yeah, a lot of the things that we're told are beneficial happen to work very similarly to things like cigarette smoke and chemotherapeutic agents and industrial pollutants. And I think that as a baseline should be something that leads us to question and concern regarding using something like this as a supplement. And it's a great point, Mike. Something we talked about also in that fatty liver series, which I'll refer back to as well, where the omega-3s have the supposed benefit for lipids by, lowering LDL, but they do so by causing oxidative stress in the liver, which actually prevents the export of fatty acids from the liver, which again looks good on paper when your doctor looks at your labs, but doesn't actually mean that it's something that's beneficial on the whole. So, very important context. Thank you for sharing.
Yeah, just important to know how this thing is working. And is it working through a mechanism that you want to optimize, or is it the same type of deal with, it's the same type of idea with statins, right? Are we going to lower cholesterol because just to lower it, or are we going to address the underlying reasoning of why it's raised in the first place? And fish oil is like congruent in that same vein, or that same like way of thinking about the problem.
Yeah, totally. All right. So I'm going to go through a few of these other studies looking at lipid peroxidation as an effect of consuming increased amounts of omega-3s. And this paper is titled Response of Urinary Malondialdehyde to Factors that Stimulate Lipid Peroxidation in Vivo. And it states that the composition of dietary fatty acids had a major influence on MDA malondialdehyde excretion in fed animals, being the highest for animals fed omega-3 fatty acids from cod liver oil, intermediate for those fed omega-6 fatty acids from corn oil, and lowest for those fed saturated fatty acids from hydrogenated coconut oil. So just pause there. MDA or malondialdehyde is a lipid peroxide product. So this is what happens when those lipids get damaged. And we're seeing increased levels of these things being excreted. So increased levels of them happening endogenously from the animals that consume higher levels of omega-3s, specifically from cod liver oil, which again, it's very important to consider here. We're not talking about isolated fatty acids, whatever it is, we're talking about the supplements that many people are taking and them increasing lipid peroxide products. We also, I think, referenced this study in that episode where we talked more about cod liver oil. Now, the next thing that was mentioned here, I think, is also very telling. So it says fasting produced a marked increase in urinary MDA, which tended to be higher in rats previously fed cod liver oil. Adrenocorticotropic hormone, ACTH, and epinephrine administration also increased urinary MDA, further indicating that lipolysis either releases fatty acid peroxides from the tissues or increases the susceptibility of mobilized fatty acids to peroxidation. The reason why I wanted to include this, just kind of like the hormesis tangent, I mean, we've talked considerably about the problems with fasting, and I can link back to those points in an article I've written as well. But something that Dom had brought up was, well, maybe it's okay for a healthy person to have enough omega-3s because they're going to be in a low oxidative stress environment. But for a non-healthy person, maybe they need to be more concerned. Now, this is despite the fact that normally these are recommended for non-healthy people to become healthier. So if that's the case, if someone's already healthy, what's the point in some ways? And also that's still huge, because then you're still saying, okay, if anybody has any health issue, anything from hypertension to cancer, don't consume omega-3s. That is very different from the general narrative of consume omega-3s. It helps with everything, and all-cause mortality and all of that. But the other thing here is fasting increased MDA, and it did so more so. So it increased lipid peroxides for all groups, but it did so the most in the group fed cod liver oil. So this is not a matter if you're healthy, you're fine. If you're healthy, you experience oxidative stress all the time when you do your fast, when you exercise, when you do your cold thermogenesis, whatever it is. Now, we've talked extensively about those things. Again, I'll reference the hormesis series and things like that. And this is part of the reason why we don't recommend intentionally inducing stress for the benefit of stress itself, instead doing it for specific effects in contexts that make sense, like proper amounts of exercise and things like that. But even in a healthy individual, and we'll actually talk about this as well in athletes in a moment, in one of these other studies, even in a healthy individual, you're leaving yourself more susceptible to greater amounts of oxidative stress anytime you're introducing yourself to oxidative stress, which is nearly always. That stress is unavoidable. We've talked about this too in the hormesis series. And so I think it's a pretty weak argument to say, well, if you're healthy and not experiencing oxidative stress, you're all right, when just a fast or a bout of exercise or anything else will do so.
Yeah. The other thing I want to mention here, specifically with all these things. So what they're talking about here specifically, they say with adrenocorticotropic hormone and epinephrine administration increase urinary MDA, further indicating that lipolysis either releases fatty acid peroxides from the tissues or increases the susceptibility of mobilized fatty acids to peroxidation. I think there's a couple things going on there. So first, the rats that are fed the cod liver oil have now stored these fatty acids inside their fat tissues. And so one of the functions, one of these hormetic pathways that are induced by the polyunsaturated fats that we mentioned was PPARs. And so again, we're going to get into this in probably another episode, but PPAR gamma signaling, which is upregulated by fish oil and the lipid peroxides by fish oil, induce the storage of these fatty acids inside the adipose tissue. So it's kind of like a protective mechanism as well. Where are all these lipid peroxides coming from? Okay, shove them in the fat tissue. And so now what winds up happening, and this goes to your point, Jay, is that when you're put under any circumstance of stress, so if you're fasting, or as an example here, you have a release of epinephrine, which you can have in exercise, which you can have during exam stress, which you can have if you're startled, which you can have under numerous circumstances, and it also releases an adrenocorticotropic hormone, which is the signaling molecule before you get to cortisol. When you release these hormones, and then these hormones mobilize fat stores, so they basically say, hey, we need more substrate. All right, fat, pump out the fatty acids, and you start pumping out the fatty acids. If you've loaded your fat stores up with fish oil, corn oil, so omega-3s and omega-6s, when they start to get liberated, now you have an increased oxidative stress because you are liberating a bunch of unsaturated fatty acids. And they're saying that they increase that the hormones in cells are increasing the likelihood of these fatty acids to being peroxidized. I think just liberating the fatty acids into circulation will allow them to become peroxidized because they are peroxidized under many circumstances relatively easily. But then the other thing to keep in mind is that these hormones, and we've talked about this in other episodes, drive fatty acid oxidation, and fatty acid oxidation in and of itself drives an increased ROS in the mitochondria. So you have a dual fold effect. If your tissues are loaded with polyunsaturated fatty acids, your fat tissues, and whenever you're put under any type of stress, you're going to liberate these fatty acids. Those fatty acids are going to, if they're high in unsaturated fats, will probably peroxidize just in the liberation process and circulation. And then these hormones are driving fatty acid oxidation, which will increase ROS as well. And then now you have an increased ROS of the mitochondria, and then you have an increased lipid peroxides and then fats that are likely to become lipid peroxides. So it's a recipe for disaster overall, loading your tissues up on these fats. And again, the polyunsaturated fatty acids are kind of like dynamite that's just hanging around. And in any type of stressful situation, is going to be that spark that's going to light the fuse. So it doesn't make any sense to, as you're saying, to use these to help for healthy people to stay healthy. If they're starting to load their tissues up of these fats, you start putting them under stress, and now their bodies are gonna collapse under the lipid peroxides and that are being developed from these different circumstances. So yeah, it's not a good idea, and the stress, and this goes with kind of like against the hormetic ideas, is like fasting overnight induces the release of stress hormones. Being startled, getting emotionally upset, having a workout, going for a brisk walk can upregulate some of these hormones. It's not that you don't ever want to upregulate these, but to try to like constantly push for these different hormones and then load your tissues up on unsaturated fatty acids is just a terrible combination in the long run. It's how you would, at least from my perspective, take a healthy person and then make them unhealthy. It is like one of the best ways to do it.
Yeah, absolutely. I think that's a great way to put it.
Yeah.
Now that you're likely questioning your omega-3 supplementation, you'll likely want to know what you should do instead. So if you're dealing with symptoms like chronic cravings and hunger, low energy or fatigue, joint pain, weight gain, digestive symptoms like bloating or slow motility, if you're dealing with brain fog, poor sleep, or hormonal imbalances, or any other low energy symptoms or chronic health conditions or issues, then head over to jfeldmanwellness.com/energy, where you can sign up for a free energy balance mini course, where I'll walk you through the main things that you can do from a diet and lifestyle perspective to maximize your cellular energy and resolve these symptoms and conditions. So to sign up for that free energy balance mini course, head over to jfeldmanwellness.com/energy. And these next studies will corroborate that as well. And they are looking at healthy humans. This one in particular was looking at healthy humans, and they excluded any signs of, someone being unhealthy, consuming a lot of alcohol, smoking, medical conditions, which includes anything as small as hypertension, high blood pressure, hyperlipidemia. So if you have high cholesterol, you were excluded. So this is just healthy humans. And the title of this paper is Lipid Peroxidation During Omega-3 Fatty Acid and Vitamin E Supplementation in Humans. And they state that in those supplemented with omega-3 fatty acids, EPA and DHA increased in plasma phospholipids, and plasma MDA and lipid peroxides increased. Breath alkane output did not change significantly, and vitamin E intake did not prevent the increase in lipid peroxidation during menhaden oil supplementation. So this is a fish oil. So they used fish oil. It increased EPA and DHA and the phospholipids, and vitamin E did not prevent the increase in lipid peroxidation. The results demonstrate that supplementing the diet with omega-3 fatty acids resulted in an increase in lipid peroxidation as measured by plasma MDA release and lipid peroxide products, which was not suppressed by vitamin E supplementation. So if you're very healthy, not a single, issue as far as hyperlipidemia, hypertension, obesity, smoking, anything else, and you're consuming antioxidants, quote unquote, like vitamin E, and you're consuming fish oil, you're going to have increased lipid peroxidation due to the fish oil. So just exactly what we were just discussing, what you were discussing, as far as this being a bad idea for healthy and unhealthy humans based on these results.
Yeah, and this is something, you can see this in cell culture studies as well. They'll expose the cells to increased amounts of arachidonic acid and DHA, and then they'll expose them to something like hydrogen peroxide or whatnot. And then it'll also expose them to vitamin E simultaneously. And the vitamin E protects some, but not entirely, from the lipid peroxides that are formed. And this is also something I don't like to use as evidence, but Dr. Pete had mentioned previously that vitamin E doesn't fully protect against what goes on with the polyunsaturated fatty acids. And that's also not to mention that the vitamin E won't be able to fully protect against the metabolites either. So you have not only the lipid peroxides, but then you also have the metabolites coming from the polyunsaturated fatty acid sources as well.
Yeah, it's great. Great points. And yes, like introducing some vitamin E, especially directly to a cell, can certainly help. But in general, the consumption is not going to be enough to outweigh this. And so when we were referencing back to that fatty liver series, using vitamin E or chelating iron helped to prevent some of the peroxidization and the effects of polyunsaturated fats in the liver. But again, I'm pretty sure that was an in vitro situation. So it's only going to help so much. And it still certainly doesn't make vitamin E supplementation a good idea. But as we continue on looking at omega-3s in healthier people, this is a study looking at 6 weeks of omega-6, or excuse me, 6 weeks of omega-3 fatty acid supplementation in judo athletes. The title is Effect of 6 weeks of omega-3 fatty acid supplementation on oxidative stress in judo athletes. And the quote states, the aim of this investigation was to assess the effects of 6 weeks of EPA and DHA supplementation on resting and exercise-induced lipid peroxidation and antioxidant status in judoists. Significant interaction effects were between supplementation and time on resting MDA concentrations and Rmax were found, with elevated values in the omega-3 long-chain PUFA group after supplementation and no change in the placebo group's levels. The authors observed a significantly greater nitric oxide and oxidative stress increase with exercise in the omega-3 long-chain PUFA group than with placebo. These results indicate that supplementation with omega-3 long-chain PUFAs significantly increased oxidative stress at rest and after a judo training session. So, in these healthy people, even at rest, we're seeing increased lipid peroxidation, just like these previous studies. And if you add some source of increased oxidative stress, even a quote healthy one through exercise, you see even greater increases in oxidative stress. Kind of like what we talked about in the past with low carb, where at baseline you have all sorts of worse outcomes with thyroid status and stress hormones and everything, but you're also increased in terms of your susceptibility to stress hormones and their downstream effects anytime you introduce a stressor on the system. And so we see the same thing here with the omega-3s.
Yeah. I don't have too much to add to the judo one specifically. I think we're getting the point across. As far as what I do want to add specifically. So 2 things. Before, I think you mentioned that vitamin E supplementation may not be a good idea, but I think you meant to say vitamin E supplementation is still a good idea. It just doesn't fully solve the problem of lipid peroxidation. And then
I must have misspoke, because I do think vitamin E supplementation is a good idea. It just isn't able to fully account for the consumption of these things. So I think what I was trying to say was, just because you're consuming just because you're consuming vitamin E doesn't mean that it's then okay to consume or a good idea to consume omega-3s.
Yeah, exactly. I didn't think you meant it that way. I think it was just the phrasing. Then the second piece I want to mention is same thing. I can hear somebody saying, well, my omega-3s are this special form and they have, some type of antioxidant, like all these antioxidants present, and it's in an amber bottle, and I've refrigerated it and it's never been above X temperature. But we have discussed previously that number one, you're going to be introducing these fats now at 98.6 degrees, which is body temperature. And then the other thing is just going through the digestive process itself is likely to oxidize the omega-3, especially if you have any type of iron inside that meal. So just other things to keep in mind, because I can already see that forming. Well, my omega-3 supplementation won't do that. It's like most likely it will.
Yeah. And there are a couple studies that we'll be going through, and we went through it in that other episode, looking at cod liver oil and fish oil and how it'll still oxidize in the intestines and internally. There's also some papers here looking at fish oil with antioxidants and also pharmaceutical grade fish oil as well in different contexts. So they do really control for that. That's a great point to mention though. And this next study, the reason I want to bring it up is because it also is one that notes on the loss of omega-3 fatty acids as a result of lipid peroxidation. And so the title of this paper is Enhanced Level of Omega-3 Fatty Acid in Membrane Phospholipids Induces Lipid Peroxidation in Rats Fed DHA. And so I believe this is the same one that we had referenced earlier, but just to mention it again here, I'm just going to read the bolded points, which states that DHA oil intake negatively influenced lipid peroxidation in both plasma and liver. Phospholipid peroxidation in plasma and liver was significantly higher than control. And they did look at a few different types of DHA. It was DHA in triglyceride form, in ethyl ester form, and in phospholipid form. And the phospholipid form led to the least amount of phospholipid peroxidation, but it did, in terms of the plasma and liver, but it did still have an effect. But the other thing that they mention is as a result of the lipid peroxidation, So they state farther down, during microsomal lipid peroxidation, there was a greater loss of omega-3 fatty acids, mainly DHA, than of the omega-6 fatty acids, including arachidonic acid. They also, just to state these next two, these next couple of sentences are just kind of nice to wrap it up. They state, these results indicate that polyunsaturation of omega-3 fatty acids is the most important target for lipid peroxidation. This suggests that the ingestion of large amounts of DHA oil enhances lipid peroxidation in the target membranes where greater amounts of omega-3 fatty acids are incorporated, thereby increasing the peroxidizability and possibly accelerating the atherosclerotic process.
Yep. I think the message is getting very clear, Jay.
Crystal?
Yes,
that's good.
It's crystal.
That's good. This one I wanted to include because of what you mentioned earlier, which was the presence of added antioxidants. And so the title of this paper is Lipid Peroxidation Products Are Elevated in Fish Oil Diets Even in the Presence of Added Antioxidants. They state that purified corn and fish oil diets with different types and concentrations of antioxidants were evaluated for oxidation products. The AIN recommended level of antioxidant addition, and even at the addition of 100 times this level, although decreasing the level of oxidation products, failed to totally prevent oxidative deterioration in diets high in fish oil. Furthermore, other antioxidants added in excess to the fish oil diets also failed to completely suppress oxidative deterioration of the diets, and in addition, when fed daily to mice for a period of 4 weeks, caused an accumulation of lipid peroxidation products in certain organs, including the heart, skeletal muscle, and mammary glands, and in the carcass. These results provide evidence that in the preparation of fish oil diets, the addition of antioxidants at the AIN recommended level, or even levels substantially higher, 100 times higher, does not completely suppress oxidative deterioration of experimental diets.
Yep.
I think I know it's self-explanatory, but it's, just going through these, I think it's helpful to just see the results of these studies.
No, of course, I agree. It's as we go through it, we're just going to see every time we had fish oil or large amounts of DHA, you're seeing increased amounts of lipid peroxidation products. And vitamin E is not protecting it. Specific other antioxidants aren't protecting against it. And it's even happening in healthy people. And it's happening in response to, it's even worse when you give fish oil and then you have stressful situations. So there's just I'm still waiting for this context where it's going to be good to drastically increase this lipid peroxidation through fish oil.
Yeah. Well, as you mentioned earlier, hormesis has to be the only explanation. And that's why this is the last study I want to mention here talking about direct metabolic effects of omega-3 consumption and the effects on lipid peroxidation. This one is talking specifically about the fat oxidation side of things, among other things, but very parallel with what you were talking about earlier with the hormetic mechanisms as a result of harmful effects of the fish oil. And just for reference, for anyone who hasn't seen that series, the idea behind hormesis is that you're causing some damage, you're causing some stress, you're causing an issue, and then the body reacts to that with an upregulation or trying to reverse the process. And most people view this as a positive thing, but we've actually pointed out that the evidence doesn't corroborate that. And instead, this is a pretty bad way to try to lead to improved health. And so this study is looking at this in the context of omega-3s, and there's quite a few others as well. Maybe I know you alluded to a couple, but so we can reference those in the notes. But in this one, the title is Dietary Omega-3 Highly Unsaturated Fatty Acids Affect Mitochondrial Fatty Acid Beta Oxidation Capacity and Susceptibility to Oxidative Stress in Atlantic Salmon. It's also interesting that they're doing this in a animal that is normally going to have very, very high levels of omega-3s, and it still caused these sorts of issues. So Atlantic salmon were fed 4 different diets for 21 weeks. The levels of omega-3 highly unsaturated fatty acids ranged from 11% of the total fatty acids in the low omega-3 diet to 21% in the intermediate diet, and 55 and 58% in the high omega-3 diets. Increasing dietary levels of omega-3s led to increasing percentages of these fatty acids in liver lipids. The group fed the highest level of DHA had higher expressions of peroxisome proliferator activated receptor, this is PPAR, beta, and the fatty acid beta oxidation genes, acyl-CoA oxidase, and carnitine palmitoyl transferase 2, compared to the low omega-3 groups. The high omega-3 groups had reduced activity of mitochondrial cytochrome C oxidase and beta oxidation capacity, together with increased activities of superoxide dismutase and caspase 3 activities. the percentage of mitochondrial cardiolipin was 3.1 in the highest omega-3 group compared to 6.6 in the intermediate group. These data clearly show an increased incidence of oxidative stress in the liver of fish fed the high omega-3 diets. So I know that was a lot there, but I think really important things to explain. So one that we've mentioned, I believe in the past, talking about omega-3 and omega-6s, is that when we're producing energy, we talked about the issues with phospholipid membranes being unsaturated. One of the main complexes, complex 4, of the electron transport chain is cytochrome C oxidase, and it has lipid components. And when those are replaced, when they're less peroxidizable, when they're mono or saturated fats, when those are replaced with more unsaturated fats like omega-3s, it leads to major issues. It leads to increased peroxidation and decreases the function there. And when you have peroxidation there, it actually will remove those complexes from the electron transport chain, which is how they saw here that there was less than half of the cardiolipin in the highest omega-3 group versus the intermediate group, and the cardiolipin being involved in the cytochrome C oxidase there. So that's one thing that I wanted to mention. Another thing, if you actually look through this study, they showed that there was a dramatic, basically zero beta oxidation in the highest omega-3 groups. In other words, their ability to produce energy was incredibly suppressed by these high levels of omega-3s. And so as a result, you saw an increase in upregulation of the genes for fatty acid oxidation and those enzymes, as well as the PPAR beta activation and expression. And from the hormetic standpoint, normally they would point to a study like this and say, look, omega-3s are good. Yes, they decrease beta oxidation, but look, they increased all these things that helped to increase it. So this is actually good for you. But when you look at the study, despite the increase in expression of all these things, their capacity for fat oxidation was nearly zero. It was incredibly low, despite all of these hormetic reactive adaptation effects, which is the same thing you see in diabetes and other chronic health conditions. You see upregulations of things like autophagy and uncoupling in response to hormesis, and then you see worse outcomes. It doesn't actually improve the outcome. It doesn't actually give you the effect that it's supposed to, that's purported to. So you see that here, in addition to seeing, of course, the increased oxidative stress and things like that from the high omega-3 diets.
I think the most interesting piece of this for me is because the effects aren't surprising, especially considering what you see in all the rat and mouse studies, is that this is actually in salmon. So salmon are organisms that generally have higher amounts of omega-3s in their tissues, specifically to deal with living in a very cold environment. And they're responding negatively to really high intakes of omega-3s and an incorporation of high amounts of omega-3s into their tissues. And the effects are, again, the other thing I find really interesting here is that the cells are upregulating these adaptive responses, these stress responses, the PPAR beta, and then the PPAR beta helps to upregulate fatty acid oxidation and whatnot in response to the inability to actually oxidize fats appropriately because of the damage to the mitochondrial function from the high amounts of omega-3s. So the time course, I think, is really important when you're trying to understand these mechanisms. It's lipid peroxidation damages mitochondrial function and also triggers or signals, hey, we have these damaging products present. Let's upregulate all these pathways to deal with them. And so even when you look in some of the other cellular studies or some of the rat studies, and you look at the provision of DHA and high omega-3s and fish oil and things like that, you see, glutathione S-transferase is higher. Reduced glutathione levels are higher. Superoxide dismutase levels are higher. All these different antioxidant enzymes are higher. Heme oxygenase expression is higher, right? And it's like, that is not a good thing, especially because you'll look at like the control groups, and the control groups will actually have less of those antioxidant enzymes and less of this signaling. It's like, look, this is the benefit. It upregulated all these things. And it's like, it upregulated these things because it was causing problems. And so then the cell had to respond and protect itself from the lipid peroxides, from the damage to its energy production systems, and start to detoxify the lipid peroxides and the lipid mediators that are produced from these types of fatty acids. So that's a really important piece, is damage or danger signaling and then the upregulation versus like, is the cell having a better antioxidant capacity because you have less reactive oxygen species and less lipid peroxide. So you just have more antioxidant substrate, vitamin C, vitamin E, glutathione, whatever the reason is, because you're not having all of the oxidative stress versus inducing oxidative stress and then having the response. And or the other thing here is, are you having increased energy metabolism or upregulation of some of these different things because the cell is like responding to having a high ATP state and increasing mitochondrial production and energy flux? Or is it energy is so damaged that you need to upregulate defensive pathways to try to get things going again, to try to move things along? And so the context is super important. I think this is a great example of this. And again, this is in salmon. So like salmon are technically supposed to have a decent amount of omega-3s in their tissues. You would think that they had some type of evolutionary mechanisms to be able to handle omega-3s. And so the fact that you're seeing this trend is just, it's kind of interesting overall.
Yeah, absolutely. And it was a very, very high omega-3 diet, but still just interesting to point out. And the larger notion within hormesis that if you are having issues with damage not being cleaned up, right, you don't have enough autophagy, or if you're having issues with mitochondrial respiration where you're not producing energy well, what you need to do is you need to create more damage. That's how you get it cleaned up. You need to impair mitochondrial respiration to activate backup systems to force mitochondrial respiration. That is the perspective, as opposed to, let's actually fix mitochondrial respiration and why you're not producing energy. Let's actually increase the capacity for cleanup, so to speak, or let's reduce the amount of damage being produced through other means that aren't actually creating more damage. Like, even just on the face of it, when you actually get underneath the flashiness of hormesis and, buying fancy saunas and cold baths and doing, fasting and ketogenic diets, all these things that are unique and different and on the forefront, so to speak, right now, or consuming fish oil falls in that same category. Like, once you dig beneath that and get below the flashiness and actually see what it is, like see it for what it is, and also see that it's the same perspective, the same argument that the industrial chemical companies are making for polluting the environment, and say, it's the same argument that the doctors were making for why cigarette smoke is good for you and things like that. I mean, then you really start to, it really starts to fall apart without even getting to the research, which then I think is even further. So yeah, it's nice to see omega-3s fall into that same category. And I don't have anything else to add here as far as showing them increasing lipid peroxidation, other than I would just add also that not only is this just a problem on its own, but we also very clearly see associations, as you were alluding to, between increased oxidative stress, increased lipid peroxidation, and every chronic health issue, aging. You see this in humans, you see it in other species. I mean, this is very clearly not a good thing. So I think it's some really important evidence to consider. All right, so the next handful of studies that we'll be going through are going to be showing that the increased consumption of omega-3s through supplements doesn't actually improve chronic health conditions or mortality in humans. And of course, this is despite increasing the omega-3 content of the phospholipids, which we know to happen when we use omega-3 supplements. So this is seeing in action, this is actually looking at the randomized controlled trials where omega-3s are given and seeing if there's actually an improvement in outcome. And I will say there is conflicting research here. Some studies support it, some meta-analyses support it and say that there is some benefit, and some do not. We're just going to be highlighting the ones that are, major meta-analyses, recent ones, looking at this and showing that there's really not much of an effect. And again, you can find conflicting data here, but that alone is enough to say that, or at least to not be able to say convincingly that there is a benefit to omega-3 consumption. So that's really the main point we want to drive home here is that there's quite a bit of evidence that this is not actually any beneficial, or necessarily harmful either in these contexts. The other thing too is that with these meta-analyses, they're all going to vary based on the details, based on which trials they include, which ones they don't, what they consider to be high quality evidence, how they weight the different trials. And so that's why you're going to get conflicting data, and it's all a lot of it is interpretation. It's based on author's interpretation and then the person who's reading it, their interpretation. So it's just like anything in quote science, it's not black and white. But anyway, we're going to be highlighting a lot of these papers that do suggest that there's no benefit to omega-3 supplementation in humans for chronic health conditions or for mortality.
Yeah, I think the overall point here is that it's not necessarily a settled situation on omega-3 specifically, because you have some evidence where there seems to be some benefits, at least indirectly. So it doesn't necessarily mean that the omega-3 supplements are beneficial in and of themselves. For example, the studies that we covered discussing the associations between the red blood cell and total red blood cell phospholipid concentration omega-3s and then total mortality. So, there's that piece of evidence, which is largely indirect. And then you have a mixed bag of evidence over here on this side with omega-3 supplementation use in humans and then the subsequent outcomes from there. And you also have a degree of mixed bag of evidence in fish consumption, and like fatty fish consumption versus lean fish consumption in terms of the benefit, and we'll get into that in terms of the benefits of those in different types of outcomes. And then you also have some mechanistic underpinnings where omega-3s could actually be highly problematic. And then there also is research there showing that these omega-3s or sources of omega-3s can be highly problematic through multiple mechanisms: the lipid peroxidation, incorporation into the membrane, change in mitochondrial energy dynamics or energy production and things along those lines. So it's when you're like weighing all of these pieces together, it's like all these things for me give me pause before I say, okay, well, this section of data or this set of information saying, oh, this is a good thing to do. And then when you start, and so like when you bring this next context in that we're going to jump into, and we start to see it's kind of a mixed bag, then it's also, it means for me that, okay, I need to do a bit more digging to figure out where the discrepancy is and what is it exactly going on. Because there has to be a reason or some explanation for why in one circumstance you're having all these problems, and in these other circumstances, perhaps with some of the indirect measures, you're starting to see some of the different benefits. So I think this is important to see for the whole, that there's like multiple contexts and a larger picture to look at here. And then the discrepancies in these different areas make things very important to give pause before, you start slamming cans of mackerel and things like that.
Yeah. Or even worse, omega-3 supplements.
Yep.
And, we've gone through the pretty clear mechanistic data, data both in humans and animals showing a lot of mechanistic problems with lipid peroxidation when it comes to increasing the consumption of omega-3s. And then there will be, we've gone through some pretty clear data in animals as well, and we'll come back to or go back through some more data in animals showing that, showing the effect on lifespan and mortality. And the value in doing that, of course, not everything between a rat and a human is the same, although a lot of the physiology is very, very similar. But part of the problem with looking at a human trial of a couple of years out of an 80-year lifespan is there's a lot of other variables going on. It's way harder to control other variables, other aspects of diet and whatnot. And also, you're just looking at a very small snapshot in the lifespan, whereas you can take a mice or a rat and give them more omega-3s for their whole lifespan and see what happens, throughout that time. There's a lot more that can be controlled, and it's over a much longer span. So anyway, we'll dig into this research here showing that in humans, at most, it's really, there's not any sort of conclusive evidence suggesting that supplementing with omega-3s is beneficial for these chronic health conditions, which are often the things that they're suggested for: heart disease, depression, and on from there. So to begin, there's a meta-analysis titled "Association Between Omega-3 Fatty Acid Supplementation and Risk of Major Cardiovascular Disease Events: A Systematic Review and Meta-Analysis." This is from 2012. Just to share a couple of quick quotes. It states, of the 3,635 citations retrieved, 20 studies of 68,000 plus patients were included, reporting 7,000 plus deaths, almost 4,000 cardiac deaths. over 1,100 sudden deaths and 1,837 myocardial infarctions and 1,490 strokes. Overall, omega-3 PUFA supplementation was not associated with a lower risk of all-cause mortality, cardiac death, sudden death, myocardial infarction, or stroke based on relative and absolute measures of association. So a pretty good sample size here, pretty large meta-analysis looking at quite a few studies, and they're pretty clear conclusions of no benefit to the omega-3 supplementation. You have anything else to add before we go on to the next couple, Mike?
Nope, I think that one is, overall pretty clear. Well, I think this one would probably be more helpful than the RBC phospholipid piece of information to determine whether you should actually take omega-3s. Again, because in the previous set of arguments that we brought about with this is that multiple things can adjust red blood cell phospholipid omega-3 content. And so the supplementation, yes, that is one of the factors that can change the RBC phospholipid omega-3 content. But here you're actually seeing what is the outcome is there is like, is it going to lower mortality or affect cardiovascular outcomes or anything like that if you were going to take fish oil? Because that's ultimately the implementation that you're getting to. So here it's basically you're seeing the implementation of, okay, we're going to take fish oil and then there's multiple studies here and then we're going to analyze and see, okay, does it actually make a difference from all of these studies? And at least according to this meta-analysis, there's not a mass or a significant difference both in relative and absolute terms. So this is actually, for the implementation perspective, taking fish oil, this is, I think, a better piece of information than relying on the RBC phospholipid data.
Right. Yeah. These are meta-analyses of interventional trials, not looking at associations in epidemiology.
Yes.
Like the red blood cell ones. Yeah. So these next few papers I'm going to share some quotes from are all Cochrane reviews. There's one from 2004, one from 2018, and then one from 2020, where they're doing further meta-analyses looking at omega-3 fatty acid supplementation for cardiovascular disease. And, you can see that they've been looking at this for nearly 20 years, doing these major meta-analyses, and nothing's really changing there. There's one very small kind of minor change, but for the most part, the evidence isn't really changing based on these reviews. First one, they state omega-3 fatty acids the title is Omega-3 fatty acids for prevention and treatment of cardiovascular disease. This is from 2004. And so in this paper, they were looking at 48 randomized controlled trials and 41 cohort analyses. The pooled trial results did not show a reduction in the risk of total mortality or combined cardiovascular events in those taking additional omega-3 fats, with significant statistical heterogeneity. Sensitivity analysis retaining only studies at low risk of bias reduced heterogeneity and again suggested no significant effect of omega-3 fats. So just to explain that a little bit further, they were looking at a ton of different controlled trials, and overall there was no reduction in the risk of total mortality or combined cardiovascular events in those taking omega-3 supplements. Although they said there's heterogeneity. So what that means is that some studies showed benefit, some studies maybe showed a negative effect, but overall there was still no benefit, but it was just very mixed, the results were. But then when they only looked at the studies at low risk of bias, that reduced the heterogeneity. So the studies with low risk of bias were much more conclusive and there was much less discrepancy, and they largely showed that they showed no significant effect of omega-3 fats. To go on with the next part of the quote here, they state, restricting analysis to trials increasing fish-based omega-3 fats or those increasing short-chain omega-3s did not suggest significant benefits on mortality or cardiovascular events in either group. Subgroup analysis by dietary advice or supplementation, baseline risk of cardiovascular disease, or omega-3 dose suggested no clear effects of these factors on primary outcomes. So in this part of the meta-analysis, they looked at just consuming extra fish, just consuming short-chain omega-3 fats, just looking at dietary advice versus supplementation, looking at different doses. All of it suggested no clear benefits in terms of omega-3 fat supplementation. So again, this was 2004, but I'll share some quotes from the more updated versions, largely suggesting the exact same thing. So in their next analysis, and again, I do think it's worth going through these papers a little bit, or at least just including these quotes because they get very clear on what they're looking at. It'll just help to add context.
And the Cochrane reviews are kind of the gold standard of these different reviews. Like a lot of people at least within research, holds Cochrane to a very high esteem. So when they put out analysis or reviews on these topics, these are usually some of the best reviews available.
Yeah. Great point. Thanks for mentioning that. So this next one, omega-3 fatty acids for the primary and secondary prevention of cardiovascular disease. It's from 2018, also Cochrane. They state that we included 79 randomized controlled trials in this review update and found that 25 were at low summary risk of bias. Trials were of 12 to 72 months duration and included adults at varying degrees or at varying cardiovascular risk, mainly in high-income countries. Most studies assessed long-chain omega-3 supplementation with capsules, but some used long-chain omega-3 or ALA-rich or enriched foods or dietary advice compared to placebo or usual diet. They go on to say meta-analyses and sensitivity analyses suggested little or no effect of increasing long-chain omega-3s on all-cause mortality, cardiovascular events, coronary heart disease, mortality, stroke, or arrhythmia. This is the most extensive systematic assessment of effects of omega-3 fats on cardiovascular health to date. Moderate and high-quality evidence suggests that increasing EPA and DHA has little or no effect on mortality or cardiovascular health. This is evidence mainly from supplement trials. Previous suggestions of benefits from EPA and DHA supplements appear to spring from trials with higher risk of bias. They go on to say that there is evidence that taking omega-3 capsules does not reduce heart disease, stroke, or death. There's little evidence of effects of eating fish. So this was a much more recent review stating very clearly all of these same things. Little or no effect on mortality, cardiovascular health, whether we're looking at supplements, whether we're looking at eating fish, whether we're looking specifically at EPA and DHA. No benefit to cardiovascular events, stroke, arrhythmia, not from there.
Yeah. And I think this puts into perspective of, is there something else going on with the RBC phospholipid omega-3s more so than just taking fish oil supplements or eating large volumes of fish? Now, or large volumes of fatty fish. This is not to say that there's not a benefit to eating seafood and fish. It just may be that the benefit is not directly related to omega-3s. Although here, they're saying there's little evidence of effects of eating fish specifically. So perhaps those benefits of eating fish are not playing out in the randomized controlled trials here in the analysis. But overall, again, it's not to say not to eat fish.
Right. Yeah. And we would generally recommend low fat fish, low omega-3 fish, and
white fish.
Again, it's important. Yeah. And seafood and things like that. But again, it's important to point out here that when they separate the trials based on moderate and high quality evidence versus trials with higher risk of bias, there is a clear difference in what they're seeing. And that's part of what's so difficult about looking at research is those possible biases, who is funding the research, all those things, where their perspectives are coming from and how they're analyzing things. And when those things are looked at by presumably objective third-party source, you see a clear difference. We've talked about this with the statins in the past as well, where, as soon as they introduce stricter rules in terms of how the research could be carried out, then all of a sudden you start to see different results and, on from there. So anyway, moving on to the more recent of the Cochrane reviews, a short quote here, just basically showing largely the same. This one is from 2020. It's titled Omega-3 Fatty Acids for the Primary and Secondary Prevention of Cardiovascular Disease. Same title, just the updated version. In this one, they included 86 randomized controlled trials and found that 28 were at low summary risk of bias. Meta-analysis and sensitivity analyses suggested little or no effect of increasing omega-3s, long-chain omega-3s on all-cause mortality, cardiovascular events, stroke, or arrhythmia. They did find that increasing long-chain omega-3s may slightly reduce coronary heart disease mortality, although this was low certainty evidence, and coronary heart disease events, again, low certainty evidence. Overall effects did not differ by trial duration or long-chain omega-3 dose in pre-planned subgrouping or meta-regression. There's little evidence of effects of eating fish. So again here, when it comes to the most important things like all-cause mortality, cardiovascular mortality, and all of that, there's still little or no effect of the long-chain omega-3s, but they did find with some of the more recent papers, based on low certainty evidence, that there might be a slight reduction in coronary heart disease events and mortality. So I would say that I'm not sure how valuable that is if it's not also coming along with a benefit to all-cause mortality. And again, there's low certainty evidence. Obviously, there's a lot more to be done here as far as research goes, but it is worth mentioning that there might be something there, at least based on this analysis. But yeah, I'll leave it at that.
Yeah, I think there's too many other points here too that bring it into question specifically, where you're seeing some benefits with coronary heart disease mortality, but not other areas of cardiovascular function. And then you're also seeing perhaps the benefit with the supplementation, but then not the fish, which the question would be, if the fish is also containing omega-3s, why is there not a benefit? Is it because there's other components that would be negative? But that was kind of questionable, considering that fish generally is assumed to have mostly beneficial components. Maybe trimethylamine oxide or TMAO is like the one thing that people would like argue against fish for to some extent. But yeah, overall, it seems conflicting because there's not a congruency with the other pieces in conjunction with this low certainty evidence for the coronary heart disease events.
Yeah, definitely. I don't have anything else to add there, but do you want to go ahead and share the next one, Mike?
Sure. So the next one that we're looking at here is titled Associations of Omega-3 Fatty Acid Supplements Use with Cardiovascular Disease Risk. This is a meta-analysis of 10 trials involving 77,917 individuals, and it's from 2018. So they start here and they say previous meta-analysis or meta-analyses of omega-3 fatty acid trials, which were limited by being incomplete, including trials of dietary advice to increase fish consumption or failure to distinguish the effects on a wide range of subtypes of cardiovascular disease. In contrast, the present meta-analysis demonstrated that omega-3 fatty acid supplementation had no significant effect on fatal coronary heart disease or any other cardiovascular disease subtypes. So basically what they're saying here initially is that previous meta-analysis had some issues in terms of the trials that they were analyzing. So basically some of them were looking at just increasing fish consumption, or they weren't distinguishing the different types of cardiovascular disease. So in this one, they specifically corrected that, and they demonstrated that they specifically looked at omega-3 fatty acid supplementation, and they found that it didn't have any significant effect on coronary heart disease or any other cardiovascular disease subtypes. So instead of looking at trials that were saying, oh, we're going to have fish, or we're going to have advice to increase fish, or omega-3 supplementation, they narrowed in on omega-3 supplementation. And then instead of just kind of like looking at heart disease in general, they went in and looked at coronary heart disease and then other subtypes of cardiovascular disease. And they basically found that there wasn't any benefit when they got very specific about the types of questions they were asking about the research. The next quote here is they say this meta-analysis of 10 randomized controlled trials involving 77,917 participants demonstrated that randomization to trial arms with omega-3 fatty acid supplementation for a mean of 4.4 years had no significant effect on either of fatal coronary heart disease, non-fatal myocardial infarction, which is a heart attack, stroke, revascularization events. So that's kind of you're going in and you have a blockage in the heart, they can put a stent, things along those lines, or any major vascular events. Importantly, this meta-analysis also demonstrated no significant effect on major vascular events in any particular subgroups, including prior vascular disease, diabetes, lipid levels, or statin use. Likewise, the present meta-analysis showed no significant association of omega-3 fatty acid supplementation with all-cause mortality or cancer. And basically, they're saying the data wasn't shown for this, but they didn't find a significant association there. So essentially, what they're looking at here is 10 randomized trials with a huge population, 77,000. They looked at the omega-3 use for almost 4.5 years, and basically they didn't find the benefit in multiple different subgroups of cardiovascular disease. So that's strokes, that's heart attacks, that's having to go in and have revascularization, so getting stents put in, or having the balloon angioplasty to open up the veins, or a CABG, or anything along those lines. And then essentially they also didn't see a benefit with all-cause mortality or cancer. And I think this study is very important and very specific, or this meta-analysis is very important and very specific, because it got very precise about the types of questions it was asking, and it was specifically, what is the effect of omega-3 supplementation on these different outcomes? So these different subgroups of cardiovascular disease, and then all cause mortality and cancer. And that narrowing these things down is, I think, quite important overall to the picture, because the ultimate goal is to parse out where is the benefit actually coming from with fish consumption or omega-3 consumption, or is there benefit between the two? Because if omega-3s are not the actual beneficial component of fish, then taking this supplement of omega-3s to achieve these benefits, because there's some indirect associated values, but you're not actually seeing the benefits when you use the supplements, it makes the supplements largely moot. It makes it probably, and then the question, and the other piece I think to add to this is, if you have no negative effects of omega-3s, then not only would it be like null or moot, is there actually a negative effect that could occur from taking the omega-3s long term? And that's what you want to parse out. And it's like, if you had a substance that was showing a benefit and it didn't have this other side of it where, there's perhaps some negative components, then at the minimum, it doesn't have a negative effect, or it doesn't have any effect. And then at the maximum, perhaps it's actually beneficial. And for certain, you can think of something like this where you're taking like certain B vitamins that are water soluble, and as long as you don't overdose them, for most people, they may actually have a beneficial effect. And then the downside is relatively minimal. But the problem with omega-3s is that there may actually be a pretty significant downside, and the mechanisms for this are already laid out, which is why we're doing this entire podcast, essentially, is to put all of these in context. And so basically you're seeing with these different trials, the supplementation is not actually having a benefit. And as you start to get more specific on the research that you include in your analysis, and you start to get more specific on the types of questions you're asking about the research, you start to see that the benefits are not actually playing out the way that we see. And this becomes especially important, again, because there's multiple logical steps that you have to go through here. If my omega-3 content in my red blood cells decreases my risk of mortality, and I know that omega-3 supplementation will increase my omega-3 content in my red blood cells, then you're assuming that taking omega-3s will decrease your mortality. But what we're seeing here is that taking omega-3s is not doing that. So there must be some other modifying factor in the middle as far as omega-3 content in the red blood cells. And even worse is that taking the omega-3s may actually be worse because we have these known negative mechanisms. And so it's important to have that entire context before you make, or at least for me, before I make decisions about taking omega-3 specifically. I want to fully understand, does the mechanism make sense? Is there associations there? And then are we also seeing benefits when these things are given in real life?
Yeah, absolutely. I don't have anything to add, but there are just a couple more meta-analyses to mention here that are important. So this one is from 2020. It's the STRENGTH trial. So it's titled Effect of High-Dose Omega-3 Fatty Acids versus Corn Oil on Major Adverse Cardiovascular Events in Patients at High Cardiovascular Risk, the STRENGTH Randomized Clinical Trial. And this is particularly important because this is in patients at high cardiovascular risk. These are largely patients who are on statins as well. And so these are the patients who should be helped the most, presumably, if omega-3 fatty acid supplementation is helping for cardiovascular disease risk. And so if there was ever a population to see any benefit, it would be the most at-risk population. And what they found, there's two quotes here. The first states that when 1,384 patients had experienced a primary endpoint event of a planned 1,600 events, the trial was prematurely halted based on an interim analysis that indicated a low probability of clinical benefit of omega-3 CA versus the corn oil comparator. And the omega-3 CA, this is a formulation. It's a carboxylic acid formulation of EPA and DHA of long-chain omega-3s. They're comparing that to corn oil. So again, they stopped this trial early because it was indicating a very low probability of any clinical benefit. The next quote, they state, among statin-treated patients at high cardiovascular risk, the addition of omega-3 CA compared with corn oil to usual background therapies resulted in no significant difference in a composite outcome of major adverse cardiovascular events. These findings do not support the use of this omega-3 fatty acid formulation to reduce major adverse cardiovascular events in high-risk patients. So, of course, this is the patients that are supposed to be helped the most with omega-3s, and they were finding here that that was not the case.
I think the even worse that they didn't find the benefit in the like groups that should see the most benefit is that they didn't find benefit compared to corn oil, which is like
right.
It's it's not like there's like, oh, they didn't find benefit compared to olive oil, which
Or nothing.
there's other benefits or nothing. Yeah, it's like, no, it was corn oil, which should have arguably made everything worse. Because it also is peroxidizable. It's also a precursor to inflammatory mediators. And it's usually not like a high quality oil that you want to consume on a regular basis.
Right. So even if there was a benefit, you could have chalked it all up to a negative effect of the corn oil, but there wasn't even a benefit. It's like we talked about this with the weight loss research on ad libitum feeding, or sorry, the calorie restriction and lifespan research on ad libitum feeding and everything in rats, where all, they have these rats who are calorie restricted and these rats who eat ad libitum, and the ones who are calorie restricted happen to live longer. And then you come to find out that it's actually just because the ones that are fed ad libitum are extremely unhealthy and have a shorter lifespan than normal. And it's not actually because there's any benefit of calorie restriction. But you're not even seeing that here. You're not even seeing that there's a benefit relative to corn oil, which would presumably be worse. So you could even argue that if we know corn oil to be worse, and fish oils are equal to that, then that's a pretty bad outcome. That's pretty not very good support for fish oil supplementation. So
yeah, so you have the high risk group, and then they also got corn oil, and there still wasn't a benefit to the. They actually stopped the trial, which
stopped it early.
Which is which is really not good overall. Yeah. Okay, so the next one here is titled Omega-3 polyunsaturated fatty acid supplementation in the prevention of cardiovascular disease. And this is a 2016 paper. The first quote here, they say 8 randomized controlled trials and 2 meta-analysis were included. In patients with pre-existing cardiovascular disease, only 1 of 5 included randomized controlled trials demonstrated a reduction in cardiovascular events with omega-3 polyunsaturated fatty acids. However, the effect size was minimal, and the study was limited by an open label design and a lack of placebo control. We'll get into that in just a sec. 2, meta-analysis concluded omega-3 PUFAs do not reduce cardiovascular events in addition to standard evidence-based therapy in patients after myocardial infarction. Myocardial infarction, for anyone who doesn't know, is a heart attack. Of the 3 predominantly primary prevention randomized controlled trials, only 1 demonstrated a minor reduction in major coronary events. However, it was also an open label study. Furthermore, the safety of omega-3 PUFA should be considered. While data from randomized controlled trials have not demonstrated serious safety concerns, omega-3 PUFAs can increase the risk of bleeding and may interact with other medications that affect hemostasis, such as antiplatelet agents and warfarin. The last quote here, they say, there is currently a lack of evidence to support the routine use of omega-3 PUFAs in the primary and secondary prevention of cardiovascular disease. Pharmacists aren't ideally situated to engage in patients in the discussions of the lack of benefit and possible risk of omega-3 polyunsaturated fatty acid supplements. I think the first thing to point out here is they do mention that there's risk, and it's the bleeding and interaction with other drugs, but it's also the lipid peroxidation. And then the incorporation into mitochondrial membranes, which we've kind of discussed ad nauseum at this point. So those are other things that I would add to that. And then it's also kind of what you were getting at before, Jay, where you see studies that had a high risk of bias, but when they eliminated them from the Cochrane analysis, they weren't really finding a lot of benefit. And basically, this quotes here are indicating like what these biases could include, or what could show like a maybe not as high quality data as some of the other trials. And you see this here with open label designs with lack of placebos showing the benefit with omega-3s, or the open label studies overall showing the benefit. So it's basically when you start to get like much more stringently controlled studies or stringently constructed studies with the omega-3s, you're really not seeing the benefits overall. And this is specific to cardiovascular disease.
Yeah. Yeah. And it's one thing if those less rigorous studies that are open label, no placebo, higher risk of bias are showing the same thing as everything else. And you can say, okay, well, yeah, they're all leaning in the same direction of benefit, but they're not. Those are the outliers that are suggesting benefit. And the ones that are more rigorous are not. They're not suggesting any benefit. So yeah, I think that it's these analyses really go pretty far to demonstrate that. And I don't have too much to add. Of course, it's nice to see some warnings here about possible dangers, even if they are really not even touching anywhere near what we would argue are the real dangers of the omega-3s. But
yeah. The other thing I do want to add here is when they are showing benefits, the benefits are largely shown in conjunction with low effect or small effect sizes.
Right. Yeah, the effect size was minimal, it said. Yeah.
Exactly. So effect size, for anybody who's unaware, showing the the amount of, so significance is saying that this is a high probability that this happens, and an effect size tells us like how large the effect actually is. And so if you have a smaller effect size, you're really not seeing much of a benefit. You're seeing a very marginal benefit, even if it is significant, meaning it's unlikely to be a function of chance. So yeah, this isn't really like a good argument. At least these aren't showing for supplementing omega-3 specifically, because even if say the benefit was even there, if it's very marginal, then, and there are other risks for it, then the question now again becomes risk versus reward. And again, they're starting to discuss some of the risks with this, but there's also others that are not really discussed overall. And again, like, as you already mentioned before, Jay, this is also a time frame. What's the risk of using these things across the lifespan? In rat studies, it's easier to see. In cell studies, rat studies, worm studies, yeast studies, it's easier to see these things because they have such a short lifespan. Whereas with humans, it's like, good luck trying to figure out the effect of omega-3s over the course of a human's lifespan. And, like when our children grow up, then they will have the knowledge. So it's like, yeah.
And I'm excited to get into that research. Also looking at what happens in offspring with omega-3 supplementation in some of these animals. So very relevant, speaking of what will happen to the children of all of the omega-3 medicated parents. Anyway, that's as far as the actual studies I wanted to share here. I don't want to go into any others. I just wanted to look at the major ones looking at mortality and cardiovascular disease. But as far as the trials looking at and meta-analyses looking at everything from depression to anxiety to macular degeneration, ADHD, anxiety, IBD, dementia, Alzheimer's, schizophrenia, pregnancy outcomes, infant outcomes, these are all things that people will point to a study here or there that it suggests some benefit, and people will talk about using omega-3s for these purposes all the time as being beneficial. But just like these studies that we shared, the evidence is not conclusive for those things either. A lot of the papers, a lot of the meta-analyses are showing at most a very small effect size, and the vast majority of time, no benefit or no, or sometimes even a negative effect. So I would just keep that in mind when it comes to any of these other disease processes as well. But, it would take too much time to dig through the research and share some of the quotes and everything from each one. I think the point kind of got across.
Yeah. And I do want to add something here specifically is that, for example, when they're talking about that the omega-3s may interact with other antiplatelet medications or blood thinners like warfarin, some of the benefits that are described to omega-3s as far as creating pro-resolving mediators and inhibiting excess platelet aggregation and things along those lines, like those specific mechanisms are of benefit. But the thing is you can get those benefits without having to rely on something like omega-3s that come with other problematic factors that we've kind of mentioned ad nauseum here. So in minimizing inflammation or inhibiting the COX enzyme or creating specific mediators, for example, aspirin can create similar mediators that help to minimize an inflammatory response. Like that's helpful. A blood thinning response inside cardiovascular disease is also helpful for many reasons. And then inhibiting things like neuroinflammation or whatnot in these different states, or adjusting inflammation in the digestive tract, et cetera, or balancing out perhaps an extremely pro-inflammatory profile that's a very high on omega-6 and increasing omega-3 intake and adjusting the eicosanoid mediators that are produced are probably like to a degree beneficial, But again, on the spectrum of benefit, ideally you wouldn't have a high amounts of either of these highly peroxidizable fats. And overall, you would keep your eicosanoid and inflammatory mediators low. So it's like perhaps there is some benefit from the omega-3s in these for these specific mechanisms, but there's also problems with the omega-3s, and these mechanisms can be hit through many other substances and options. And then the other thing is like having them in and of themselves on the problem, like as far as spectrum of optimization, they're not on the far side towards more optimal, even if they have some of these specific benefits in these very specific contexts. Without taking consideration the other side effects of them, like sure, you could make an argument for it, but I think it's important to always have those other pieces in context.
Yeah, and even with those other mechanisms, like the anti-inflammatory effect being something that actually works through immunosuppression. I mean, I think I would even be careful to call them benefits. I would say that they are certain effects, but just like the supposed effects here, the larger context says it all and is incredibly important, as opposed to just saying, hey, look, it has this effect, so let's take the omega-3s. So yeah, I'll certainly be linking back to previous episodes where we've brought about some of that context. I did want to just mention one other area here, looking at fish oil supplementation and insulin sensitivity and diabetes being something that I'll cite some research looking at that and actually showing some negative effects in terms of fish oil supplementation on insulin sensitivity. All right, we're going to end that episode there and pick back up in part 3, where we'll be going over the studies showing that omega-3 consumption decreases lifespan and increases disease processes. We'll also be going over the potentially harmful effects of omega-3 usage during pregnancy on offspring. We'll be going over the data in native cultures showing that omega-3 intake does not improve cardiovascular disease or mortality. And we'll also be discussing the extremely healthy populations that consume high carb and high saturated fat diets with almost no omega-3s. If you did enjoy today's episode, please leave a like or comment if you're watching on YouTube. And if you're listening elsewhere, please leave a review or 5-star rating. All of those things really do a lot to help support the podcast and are very much appreciated. To check out the show notes for today's episode, where we'll link to the studies and articles and anything else that we referenced, you can head over to jfeldmanwellness.com/podcast. And if you're looking to optimally support your metabolism and lose weight, improve your digestion, get amazing sleep, rebalance your hormones, boost your energy, and so much more with clear action steps and strategies, along with personalized guidance from me, then head over to jfeldmanwellness.com/solution, where you can find all of the information for the Energy Balance Solution program. This program includes customized health coaching, a video library, which includes videos on restoring gut health, losing weight without destroying your metabolism, boosting your metabolism, getting amazing sleep, how to rebalance your hormones, and tons more. It also includes resources like a sample meal plan and supplement guide, as well as a private community. So head over to jfeldmanwellness.com/solution to check out all the details. And with that, I'll see you in the next episode.